All right, Chris, what's the problem?
It is y equals 8x squared plus 40x plus 37.
Plus 37. All right, so what are the steps that we've always done?
So the first thing that we have to do is get put x squared and 40x in parentheses and leave out the 37. Prepare to complete the square.
Just prepare to complete the square.
So I get y equals 8x squared in parentheses plus 5x and then plus 37 outside.
All right, so we prepare to complete the square. 37, not 73. Oh, a little issue there. Yeah, 37. Okay, so we prepare to complete the square, and then there's a little check here. Does that go back together? And it's worth just confirming in your head that that multiplied back together, distributed, plus 37 is the same as the line above?
Yep.
Everyone's happy. Great.
So now y equals 8, then x squared plus 5x, and then you do plus.
Yeah, I just copy everything down. And then completing the square is totally easy. It's mechanical in some ways. You always, every time, take half of that.
So 2.5.
Well, let's leave it as a fraction.
Okay, so that would be 5 over 2.
So that's 5 halves, and when you square 5 halves, it goes here.
So you get 25 fourths.
25 fourths.
But that's also being times by 8.
That is automatically multiplied by 8.
So that's really 200 fourths.
Oh, I was afraid you'd say that.
No.
8 times 25 fourths. Most people, I'd like to encourage you to think about reducing first and then multiplying.
So it would be 50.
So 50. We have just added 50. Without realizing it, we added 8 times 25 fourths, which is the same as adding 50. So we balance it by subtracting.
50, so you balance it out.
We're going to balance it out, subtracting 50. Okay, so this was actually completing the square, was adding this term, and then balance by adding the negative 50.
So I finished it with y equals 8 in parentheses x plus 2.5.
It's always
5 halves.
It's always half of that.
5 halves squared minus 13. And so then the vertex point was negative 5 halves, negative 13.
Good. And the only other thing I'd want to know about this parabola right now, just by looking, what's the shape? Yes?
Really steep and up.
Well, I want to be more specific than that. Yes?
Y equals 8x squared.
Yes, it's the shape of y equals 8x squared. Right, so it's the shape of an 8x squared. If I go over from the vertex 5, how far up do I go? Yes?
200.
Yeah, 5 squared is 25 times 8 is 200. So if I go over from the vertex 5, I go up 200. That's pretty steep. So we're going to graph this. And you would have graphed this on your homework. And we're going to make a quick sketch graph. So, I don't know, here's the vertex. Perfectly reasonable place to grab. It is negative 5 halves, negative 13. If I go over 1, well, I'll call this 1 unit. I would go up how far? Yes.
You go up 8.
I go up 8. I'll go up 8, but I'll say that that's 8. So the scale on the x-axis is 1 unit per, but the scale on my y-axis is actually 4 units per. I'm not going to worry about you actually drawing the axes or labeling at this point. What is important is, what is this point? If we move over 1, it's going to be negative 3 halves, and we moved up 8,
So negative 5.
so up to negative 5. And what about this point, the symmetric point?
Wouldn't it be negative 3.5 or 6 halves? Or
7 halves.
7 halves.
And also negative 5?
Yes.
Alright, so there it is. That's the graph. Kind of looks like this. This is a sketch graph. If we wanted to make it perfect, we'd spend more time. But this is good. Where's the x-axis? Here's negative 13, here's negative 5, here's negative 1, so it's somewhere right in here?
Yeah.
Alright, so I'm going to just kind of put it in there. And now I'd like to finish up the graph with a couple other features. I want to find the x-intercepts, and I want to find the y-intercept. Well, no, but now let's get it. So go back to the original. What is the y-intercept? If you look back here, 37. It's staring at us. So no matter what happens in all of our algebraic work, we don't want to leave the fact that the y-intercept is 0.37. If our graph starts to make it look like it shouldn't go through 0.37, we're going to back off and reevaluate. So where is the y-axis? If this is negative 3 halves, this would be negative 1 half. It's somewhere right in here. So I'm not going to go through, but up here, then that point is what we just say? 0.37. And now the only thing left is to find the x-intercepts. There's something nice about having this vertex form. Let's go to work on it down here. How do I find the x-intercepts? Yes?
You make y equals 0?
Make y equals 0. So that shouldn't be too bad. We make y equals 0. Then how are we going to solve this? That's a
minus. No, it's plus. No, it's minus.
Let's go back and see. Minus 13. Yeah, I did something strange there. Okay. Oops. Excuse me. That's a minus 13. So we just solved this. So that means that 8 x plus 5 halves equals x plus 5 halves squared equals 13. So x plus 5 halves squared equals 13 eighths. And we're getting to a tricky part here. That means that x plus 5 halves, I took the square root of that side, the square root of a variable quantity, equals,
Plus or minus.
oh yes, there are two numbers. The square root plus or minus the positive or negative square root. So that means that x equals negative 5 halves plus or minus, well, we'll leave it that way, the square root of 13 eighths. And we'll talk about simplifying radicals soon. All right, so there it is. So which one is on the right? What are the coordinates of that point? Yes?
Negative 5 halves plus the square root of 13 eighths.
Negative 5 halves, sorry, plus the square root of 13 eighths, and the y-coordinate 0. And this one must be negative 5 halves minus the square root of 13 eighths, 0. What is the average of this number and this number? The x coordinates there. What is the average of those x coordinates? Yes?
I think that it is the x coordinate of a vertex.
Now give me a value. Yes?
I think it would be 3 halves.
Try again. Yes?
Negative 5 halves.
Negative 5 halves. Yeah.
Adding it and then subtracting.
We are. We're going from this axis of symmetry. We are going, what's this distance? Yes?
13 eighths.
It is.
The
square root of 13 eighths. You're absolutely right. So you go from the axis of symmetry a little bit to the left, a little bit to the right. There's always that symmetry. Always, always, always. So there it is. This is the kind of thing I expect you to be able to do. This is a perfectly nice problem. My recommendation is keep the fractions. Multiplying by a fraction is not hard. You shouldn't have to pull out a calculator. Get your graph. Don't worry about attaching the graph to the axes. Rather, attach the axes to the graph. It's only a sketch. If you want to get out a piece of graph paper later, you can do that and really nail it down. But that's a good problem. That's a good result. That's a good graph. All right? I'm going to stop this.